A happy new year to you all of you, and wish this new year may be free from this COVID, and you all go to school and come to different coaching center for your knowledge, gain up your knowledge. Let's in this new year, let's start a new subject called structure of atom. So what do you mean by structure of atom? Structure of atom. You have already learned in the previous chapter that atoms, molecules, and matter. Matter consists of atoms and molecules. So, and there is a theory you have learned from Dalton's atomic structure. Dalton atomic structure. Dalton, as per Dalton theory. So, as per Dalton, atom is the smallest element which participates in chemical reaction. Is atom is the smallest element? As per Dalton, atom is the smallest element. As per his research or his data, his conclusion, atom is the smallest element. It can neither be created nor destroyed because atom is the smallest element. So then also every atom, as per Dalton, every atom has a mass and it has some chemical properties also. These chemical properties is also reflected in the compound also. From which atom came? Then atom combines in the ratio of small whole number to form compound. What is the small ratio of small whole number to compound to form compound? You already know the valency and other things. Now you'll learn also in detail about this valency here. So step by step we are going to. Now just we are going to know. So Dalton told that atom is the smallest element and it is indivisible. It cannot be divided into small parts. But suppose you take a comb and comb a dry hair. Then after combing, show the comb to the small pieces of papers. What do you observe? The comb attracts the small pieces of paper. So that means what? There is some charges generated due to the charge, positive, negative. So due to that attraction of the paper, that shows that atom also having some charge particles, consist of some charged particles. So atom consists of some charge, but then what are the types of charge? What charge particle? Positive charge, negative charge, or neutral? Now know that. But the next scientists who later able to find a constituent called electrons, J. Thomson, in 19th century. In 19th century, 1900, that there is an electron inside atoms. So J. Thomson found electrons was identified, and Goldsmith in 1986 discovered a new radiation in gas discharge and called them canal rays. And E. Goldstein in 1986 discovered new radiation in a gas discharge called the canal rays, and these rays were positively charged. So what Thomson find? Thomson and electrons. Goldstein found the new discharge in gas, new radiation in a new radiation in a gas discharge. This is called canal canal rays, and this is positively charged. So now you see that the based on Dalton theory, atom is the smallest particle. But atom chemists, different chemists, they have done the research, and now Thomson came there, found radiation, electrons as a particle of atom. Then Goldstein found a new radiation in a gas discharge, that is called the canal rays, which is positively charged. So now you come to know that atom is now also consists of electron and one positive charge also, positively charged particle. Got it? See how this is also the inventions, step by step invention of different scientists. Particle had a charge equal to in magnitude but opposite in sign to that of electrons. So electron is negatively charged. So subatomic atomic particle, that is the kinetic, that is the opposite charge, positively charged. So now electron is generally represented as E, and this is called the proton. Positive charge particle is called proton, positively charged, and then positive charge and negative charge. So inside the atom, when these two particles are present, what will happen? Positive, negative, they will react with each other, isn't it? Positively will attack the negative particle. So how it structures? Just like our solar systems. Inside the atom also, just like a solar system, they are in a definite orbit or in a circular path. So this is called the nucleus. The center is the nucleus, and it is surrounded by different electrons. Nucleus is nothing but proton, positively charged, and this is the electrons, negatively charged. So around this nucleus, the proton positively charged, the negatively charged electron is rotating continuously in a path. We'll know some. So this is basic structure. I'm just telling you for your understanding. So just like your solar system, they are in a different orbit. So continuous movement of these electrons will discharge energy. Suppose since it is rotating around the nucleus, so it will lose energy. Every electron is having some mass. Every proton is having some mass. So when a mass particle is rotating around, so it will lose the charge, energy. Then what will happen? Automatically it will fall down to the nucleus. But it happens? No, it does not happen. So what it happen? So let's first learn what is Thomson's model of an atom. It's taking time to dry because of this winter season. Thomson told that what Thomson told? Thomson told that as per Thomson's rules, this is the positive. This is the positive particles, positive sphere, and of the atom. Inside this, the are present. Electrons are present. So is it the structure positive sphere and inside that electrons are present? So what Thomson told, atom consists of positively charged sphere and the electrons are embedded in it. Electrons are embedded in it and the negative and positive charge are equal in magnitude. So this is negative charge, electron is negative. So this negative charge and this positive charge are equal in magnitude. Negative and positive charge are equal in magnitude. But it told that positive sphere and inside this negative electrons are embedded. Then and it also told that the negative and positive charge are equal in magnitude. So Dalton theory. Although Thomson theory, Thomson's model explained that atoms are electrically neutral. So this as per Thomson, as per Thomson's model, from here equal in magnitude means it is neutral. This is atom is neutral. Why it is neutral? Positive, negative, minus. Equal in magnitude, so it is neutral. When equal number of positive particles and equal number of negative particles are present, so there is no attraction, there is no reflection. But this is not the end of the research. So next law, Rutherford's model of an atom. Ernest Rutherford was alpha particles are doubly charged helium ions since they have mass of 4u alpha. Thin gold foil and alpha particles are doubly charged helium ions. So gold foil was about 1000 atom thick. Thin gold foil means thin gold foil 1000, but it is 1000 atom thick. The thickness is larger atom. So it is very thin, even smaller than the just like paper. Alpha particles are doubly charged helium ions since they have mass of 4u alpha. Mass चला कहते हैं doubly charged, double charge, doubly charged and mass of 4u. 4u means 4 unit of atom. So the fast moving alpha particle have a considerable amount of energy. So because of mass and doubly charge, the fast moving alpha particle have a considerable amount of energy. So what he did? He did he has passed the fast moving alpha particles inside this thin gold foil and saw that it is expected that alpha particle would deflected by the subatomic particle in the gold atom since alpha particles were much heavier than the protons. He did not expect to see large deflection. He did not expect to see large deflection in this for this analysis only. He has conducted this experiment. So when the alpha particle a doubly charged high speed alpha particles has passed collide with the gold or pass through a gold foil, thin gold foil. What happened? What is the observation? He has but he got some unexpected results apart from his for what he has conducted the experiment. He got some unexpected result that observation was most of the fast moving alpha particle passed straight through the gold foil. Most of the alpha particle passed straight through the gold foil. Most of the alpha particle passed straight through the gold foil. Some of the alpha particles were deflected by foil by small angles like this. Some of the alpha particles reflected at small angles, and surprisingly, 1 out of 12,000. 1 out of how many? 12,000. So, as per scattering of alpha particle by gold foils, scattering of alpha particle by gold foils. Why Rutherford selected gold foil? As he need a thin layer, as thin as possible. So he has selected a gold foil, and because the gold foil it is even 1,000 times thick than the atom. Alpha particles. Why alpha particle? Alpha particles are doubly charged helium ion. Alpha particle are doubly charged helium ion and its mass is of 4 unit for you, and it is fast moving. Alpha particle have considered, and as it is fast moving, so alpha particle have considerable amount of energy. So alpha particle is having a high speed, high doubly charged helium ion and having considerable amount of energy, and it penetrates when it penetrates through the uh, pass through the enter through the gold foil, thin gold foil. What the observation he has, Rutherford got. He got unexpected result because he supposed to get the result. So he has conducted the experiment for what? Alpha particle would be deflected by subatomic particles of gold coils, gold gold foil. Since alpha particle have considerable amount of energy, he has conducted this experiment keeping in mind that alpha particle will be deflected from gold foils since alpha particle have considerable amount of energy. But he got unexpected result, that is most of the alpha particle pass through the gold foil. So as you have seen, most of the alpha particle pass through the gold foils. Some of the alpha particle were deflected by the gold foil by small angles. Some of the alpha particle have deflected by foil by small angles, and surprisingly 1 out of every 12,000 particles appear to be rebound at 180 degree. That is, in the line, straight line, it has collided the foil, so repeated in the same straight line. This is gold foil, and this alpha rays. So alpha particles. So some of the alpha particles, you see, some of the alpha particles reflected at a small angles like this one. Some of the alpha particle reflected at a small angles. Most of the alpha particle pass through the gold foils, and surprisingly 1 out of 12,000, that is this, it mentions this, returned in the reflected back in the same 180 degree. So that is every 12,000, 1 out of every 12,000 particle reflected in this. So what this is the data he got. From this data, what is the conclusion he got? There is a positively charged centered in an atom called nucleus. There is a positively charged center in an atom called nucleus, and all the mass of the atom reside in the nucleus, and then electrons revolves around the nucleus in a circular path. This is electrons revolve around the nucleus in a circular path. The size of the nucleus is very small as compared to the size of the atom. This is the size of the atom. So size of the nucleus is very small as compared to size of atom. Small fraction of alpha particles repelled by 180 degree. All positively charged and mass of the gold atom that reflects, that gives the conclusion all positive charge and mass of the gold atom were concentrated in a very small volume. All positive charge and mass of the gold atom were concentrated in a very small volume. That is called the nucleus. So now you got, so what is that? Suppose the electron, negatively charged electron, revolve in a circular path around the nucleus. Around the nucleus, it is having some charge, some energy. So when it continuously rotate, the energy will go on decreasing slowly. So when the energy go on decreasing and the charge, it will lose the charge. So what will happen? It will slowly fall on the nucleus. So electron will slowly fall on the nucleus. And so this is the disadvantage of the Rutherford model. So because it may fall to the Rutherford had not concluded anything about this. So this is what. So next we'll see some other scientists' experiments. Wait. So now the next is neutrons. Neutrons. J. Chadwick's has discovered the another particles, subatomic particle, which had no charge and a mass equal to that of proton. That is, he named it as neutron. Who? J. Chadwick. So, a subatomic particle which has no charge and a mass equal to that of proton is called neutron. A subatomic particle which had no charge and a mass equal to that of proton is called neutron. And this neutron is present in the nucleus of the atom, of course, except this hydrogen atom. So the neutron is present in the atom. Proton is also present in the atom. So mass of an atom. So mass of the atom is generally mass of proton plus mass of neutron, as both mass are equal because present in the nucleus and mass equal to that of proton. So proton and neutron mass are equals. How are electrons distributed in different orbits? Suppose earlier you have seen that they are distributed in a different orbit in K, L, M, N or 1, 2, 3, 4 different shells, orbital shells, discrete orbits. So now this as suggested by Bohr and Bury, as suggested by the chemist Bohr and Bury, the following rules are followed for writing the number of electrons in different energy level of shells. What are the energy level of shells? In the nucleus, this is 1, this is 2, this is 3, this is 4. So this is nucleus. This is, I told earlier, you have no K cell, L cell, M cell and N cell. In number n equal to 1, sorry, n equal to 1, n equal to 2, here n equal to 3, here n equal to 4. So, number of electron in different energy level are set. These are called the cells. Different energy level are the cells or orbit. So, what are the rules? The maximum number of electrons present in a given cell is given by the formula where 2n square. What is the maximum number of electrons present in a given cell is given by the formula 2n square, where n equal orbit number or energy level index, that is n equal to 1, n equal to 2, n equal to 3, n equal to 4. It is orbit number or cell number, you can say. So, what is the formula? Maximum number of electrons present in a given cell? Here 2n square. So, in K, how much? 2 into 1 square equal to 2. K has n equal to 1. In L cell, 2 into n equal to 2 square. 4. 4 into 2, how much? 8. M cell, 2 into 3 square. 9 into 2, how much? 18. N cell, 2 into 4 square. 16 into 2, that is 32. So, according to the formula 2n square, the maximum number of electrons present in different cells, K, L, M, N, we have found it. 2, 8, 18, 32. So, now the second power rules. The maximum number of electrons that can be accommodated in the outermost orbit is 8. What is the outermost orbit? This is the outermost orbit. What? N. Outermost orbit. So, maximum number of electrons that can be present in the outermost orbit is 8. It can contain maximum 8 electrons. And what is the next rule? Electrons are not accommodated in a given cell unless the inner cell are filled. Cell are filled, that is cell are filled in a stepwise manner. Suppose electrons are not accommodated in K cell, then electron cannot be accommodated in a L cell. Similarly, if electron is not accommodated in L cell, it cannot be accommodated. Cannot put or accommodated in N cell. If N cell is don't have any electron, then you cannot accommodate it. Electron cannot be accommodated in M cell, N cell. So electrons cells are filled in a stepwise manner. That is, once one cell is filled, then it will come to the next cell. So sequentially, once K cell is filled, then it will go to the L cell. Once L cell is filled, then it will go to the M cell. Once M cell is filled, it will go to the N cell. Got my point? Now you are clear about this? I am going to type out and we'll learn some. Now we'll know what is valency. As we have learned that The electrons are filled in different cells in a stepwise manner. Once one cell is filled, then the next cell will be filled. So, electrons present in the outermost orbit or shell of an atom are known as valency electrons. Electrons, what is that is present in the outermost shell. So, outermost shell. Here, how many electrons are present? These electrons, that much of electrons is called the valency of that atom. Outermost shell of an atom can accommodate maximum of 8 electrons, but it can be only maximum 8 electrons it can accommodate. The outermost shell can only accommodate maximum of 8 electrons. Atoms of element whose outermost shell is filled with 8 electrons shows a little, so it is already in little chemical, so little chemical activity. Why? Because outermost electron maximum capacity is 8. So if it is its maximum capacity is 8, so how it will combine with others to get the outermost electron as 8? So it has less or little chemical activity or no chemical activity at all. Combining capacity or valency is, that is combining capacity or valency is, combining capacity or valency is 0 if the outermost orbit already have 8 electrons and is called insert element. Insert inert element, inert element. And helium has 2 electrons. For example, helium has 2 electrons in its outermost shells. So helium, it has 2 electrons in its outermost shell. Combining capacity of atom of element means tendency to react or form molecule with same or different elements. Combined, what is the combining capacity? Combined capacity is also depends upon the electrons present in the outermost shells. So combining capacity is means tendency to react or form molecules with the same or different element. That is to attain the outermost shell maximum 8 number of electrons. Explained as an element. To attain a fully filled outermost shell. An outermost shell which had 8 electrons was said to octet. Already has 8 electrons, so that is that shell is called. So already that atom is in octet condition or inert condition or less tendency or little chemical activity, less tendency or no tendency to combine the result. Atoms would thus react so as to achieve an octet in the outermost shell. If it is it has the outermost shell, it has less than 8 electrons, like this 2 electrons in helium. So in less than the octet 8 electron was said to possess an octet. The outermost shell which has 80 electrons was said to be possess an octet state. And atom thus react so as to achieve an octet in the outermost shells, done by sharing, gaining or losing electrons. That is in chemical reaction, whether it is sharing or attaining or losing electrons. So the outermost orbit or the element should attend a octet so that a compound can be formed. So how much what is the maximum electrons that can be present in the outermost shell? It is 8. The number of electrons in the outermost shell gives us directly the combining capacity of the element. So it shows if outermost orbit or shell is has already 8 electrons. It is noctet or little chemical activity tendency, no tendency to react. If it has less than 8, then it has tendency to achieve the react with others or share by or to attend the octet state, that is to attend 8 electron in the outermost shells. The number of electrons in the outermost shell gives the directly the combining capacity of the elements. Number of shell in the outermost shell gives the combining capacity. Suppose it has 2, so the combining capacity is more. So it will have 7 combining capacity is still there, but it will be less. So number of electrons in the outermost shell gives the directly the combining capacity of the element. So combining capacity means valency. So hydrogen or lithium or sodium atoms has 1 electron. Hydrogen, lithium and sodium. Hydrogen, lithium or sodium atoms has 1 electrons in the outermost shell. So what is the valency? 1. So each one of them will lose 1 electrons. When they will combine, they will lose 1 electron because its outermost shell is only having 1 electrons. They will lose 1 electrons by combining or reactions. So they are said to be of valency of 1. Valency of magnesium is 2, valency of aluminum is 3, and I've given it some examples. You can find many examples in your table, in your books. It is there. But fluorine, suppose the outermost shell, yeah, I'm giving you an example. It is having 2 electrons. So while combining or 1 electrons or 3 electrons or 4 electrons, so number of electrons in the outermost shell, maximum is 8 and now is less than is 2, 3, 4. That means it has more tendency to lose than to gain to attain octet conditions. So, but in I'm giving you an example. So, when to lose, when to gain. Suppose in fluorine has 7 electrons in its outermost shell. So, its valency could be 7, but it is not, because while reacting with other, it is easier for fluorine to get 1 electron instead of giving 7 electrons. So it is easier for fluorine to get 1 electron instead of giving or losing 7 electrons. So the valency is octet minus 7. So what will attend? Maximum after combination outermost shell will attend 8 electrons. So minus 7, 8 minus 7, octet condition is 8. 8 minus 7, the valency of fluorine is 1. So now you understand, if 2 or 3 or 4, then it will be easy to give. For example, give 2 attend while reacting, while having a chemical combination with other atom. So it can give this 4 electrons. It is easy to give 4 electrons. But giving 4 electrons, giving 7 electrons is easy, or giving getting 1 electron is easy. Getting 1 electron is easy. So like that you can decide the valency of different atoms or elements. Thank you. Hope you understand. Instead, you have any doubt, You can ask me here, or you can ask by commenting in my YouTube channels. I'll definitely reply you. Thank you.